Hello, my name is Ali Reza Karduni, and today I'm going to talk about exploratory spatio-temporal visualization and analytical review. This work is done by Natalia Andreyenko, Gennady Andreyenko, and Peter Gadalski. These are pioneers in the field of geospatial and flow visualization, and they have done consistent great work across past 20 years to improve the ways we can create visual analytic systems that focus on time, geography, space, and how we can combine these. So today we're going to talk about the concept of space and time and how uh, these can be combined in visual analytic systems. This is the work of this paper. In traditional cartography, we had to use a lot of different tricks and techniques to be able to tame the complexity that combining time, temporal data and spatial data brings together. For example, we had to use different colors to convey different times or different sizes, and then the information might become illegible. However, today we have computers with a lot of computing power and visual interactive dynamic power that can enable us with different techniques to kind of address this problem. So this paper mainly is focusing on the different exploratory techniques that are supported for geospatial temporal visualization. However, it is not a comprehensive set of everything. What this paper is trying to do mostly is to show you how to think about different tasks, different exploratory tasks as it relates to the type of data and the type of question that is being asked. So it's a very good way to kind of formalize and conceptualize these types of tasks for your future work. Moreover, this paper is not focusing on the internal data representation or data handling methods, because that's a very different problem. It is mostly trying to focus on the nature and inherent properties of spatiotemporal data and how that can be applied to our work, how that we can kind of think about it. So at first, the most important thing about time is that it is mostly about changes that occur over time. Now, these changes could be existential changes, the type, for example, whether something starts to exist, appear, and disappear, whether a building in the past 10 years has appeared in this, in this neighborhood, or then it has been demolished. So that's one type of change that we can think about, the type of data that can represent that. More changes in spatial properties. So has the location changed? Has the shape changed, or size, orientation, altitude, height, gradient, and volume? These are all the spatial properties that we can think of changing over time. Changing in attributes and thematic properties is another way that thing that we can visualize and think of when we're thinking about geospatial and temporal visualizations. For example, qualitative has that, is this area now residential in comparison to commercial a year ago, or whether the population in this region or in this city is increasing or decreasing. So this is an example of such map, but as of now, this is a static map that is changing the increasing or decreasing of populations in the United States from 1990 to 2000. Now, the blue colors are representing when the population has decreased, and the red colors are depicting areas that the population is increasing. Now, imagine using these techniques and the querying and interactive ways we can start changing the times that we are looking at and making this visualization much more meaningful and powerful, more than what it is right now. But first, let's talk about a typology of data exploration tasks is at our hand. Now, there has been a lot of work on this. There has been different ways and perspectives that people have tried to address this. These are mostly about the type of person like we are, an analyst, and the type of information needs that we have. It can be described by what is known and what is to be found. So if you think about, I know the location and time, and I want to find the type of things that are existent at this time, at this location, it becomes, an exploration task. And then it's about a sequence of operations. Now, we can think of it from different perspectives, such as, locate, identify, and distinguish, or using set theory, such as union, intersection, and selection. Now, in addition to the types of questions that we can ask, there's also the different levels that we can read the data. Think of these two questions about stock price. On a given date, what is the price of stock A? Or for a given price, on what dates was it attained? Having these questions, what are the different levels that we can think about these questions? So there has been talks about 3 levels, such as elementary reading, which is focusing on a single data element, intermediate reading, which is a group of data elements, and overall reading, which is talking about the whole phenomena. Using these, we can kind of start to create a categorization for ourselves to think about what are the available tools for us. And then from another perspective, to see the types of questions that we ask, we can, if we categorize the 3 most important elements in spatio-temporal visualization: space, time, and objects, and these 3 are mapped into the 3 W's: where, when, and what. 3 basic questions will be possible. When we think of when and where, we will get to what. For example, describe the objects that are present at a given location or a set of locations at a given time or set of times. From another aspect, when we think about when and what, we will get to a where. Describe the location or set of locations occupied by a given object or a set of objects at a given time. Now, very similarly, where and what will get us to when. So describe the times or set of times that a given object or set of objects occupied a given location or a set of locations. These 3 ways will help us kind of start analyzing our exploration tasks. Are we looking at time and location at first, and we want to get to what types of things are there? Are we thinking about things and location, and we want to see what time they have occurred? Or are we thinking about the other ways that we can look at them? Another important aspect that is evident and becomes apparent when we were thinking about computerized and exploratory interactive techniques is the task of identification and comparison. Are we trying to identify specific locations, or are we comparing 2 different locations, for example? So give the task of when plus where gives us what. Now we can compare the objects or set of objects present at locations L1 and L2 at a given time, or we can compare the objects present at a given location at times T1 and T2. So as of now, we have thought about different levels of thinking: general, elementary, and intermediate. We have thought about where, when, and what. And we have also talked about comparison and identification. Now, to kind of simplify these categorization, if we focus on time, then we can bring this 6 categories to 2. So when time is given, while other types of information are not, such as objects, location, properties, and relationship, we can describe this as when gives us where and what. So we have the time, we want to see locations and objects. Now, we want to know about time and discover time for a given information of other types. So where plus what gives us when. And then we can also simplify the different reading levels. We can keep the single element level as an important category, but both the general and intermediate, they are both thinking of our queries as a set. So in terms of the computation or visualization, they are not that different. So we can think of them as single element, which is elementary. So this image is trying to summarize what we've talked about so far. So we have search levels. We can think of them as uh, general when and what plus where. We can think of general time and elementary place and objects. We can think of elementary time and then general what and where. And then we can think of elementary when and what and where. So it's giving when, what, and where, and general elementary will have four different categories. We have two types of cognitive operations. We have identify and we have compare. And then we have a search target. Is it a location, an object given a known time, or is it a time given a location or object? Having these frameworks in mind, let's talk about exploratory techniques that that are generalized for all types of data. And then let's talk about their interactivity and dynamics exploration, which is our focus, and not really focus on the type of static paper maps that we might have. Um, so the first very general exploratory task and technique that we can use is querying, which contains two major parts: the target and the constraint. Given this example, it will be more easy to understand. A user may ask the program to retrieve all time moments when a specific object or attribute value was observed at a particular location. Now, this type of query might be, done on time and might be done on other things. For example, to provide the requested information in addition to what is already present on the screen. So this is one way that we can show the type of query. So if we have a selection, a map, and we want to look at a specific time, are we just changing the color, or are we changing the symbols of that selection? We can also remove the things that are not in the selection. For example, if we are focusing on the areas, the crimes that are happening in downtown Chicago, are we removing everything else that is not in downtown Chicago, or are we changing the color of the elements shown in downtown Chicago? And for temporal queries, we mostly have two main techniques. One of them is using a linear representation of time, which is shown in this image below. And then we can also think of a circular hierarchical representation of time for our selections. So it can also be, the results could be shown as an animation. Animation is a powerful technique that exploits the capabilities of the computer screen to rapidly update and dynamically update in content. It can be, it can show us very interesting changes over time. What properties does animation have? We can change the speed, we can change the direction of the animation. Is it moving forward in time or backward in time? We can change the extent, the start and finish moments. We can change the moments, the type of animation, whether it's going on a daily basis, on a second basis, or any arbitrary selection, and how smooth the animation is. Now, this is a very important general technique to show visualization of temporal and spatial data. Another technique that is available to us is focusing, linking, and arranging views. Focusing includes the selection of subsets and variables for viewing and various manipulations of the layout of information on the screen, such as choosing an aspect ratio, or zooming and panning, or 3D rotation. Now, having these, when we are focusing on something, to have a big snapshot, we have to have multiple linked views coordinated, so then we can keep the comprehensiveness of our application. So this image shows such a system. For example, you can focus on a specific time as shown in this area, and then the map is focusing on a specific location, and these are all the other contextual information that we might need. Another technique to show these types of information, these types of queries, is map iteration, which is general to all data. Juxtaposing multiple maps of the same location close to each other so we can compare the changes. Now, these changes could be in the what, or it could be in the when. This is a very powerful method, and it has been used in static maps. But given our ability to update and change these, it is very powerful. So existential changes are another important problem that we can look at. Whether something has appeared and disappeared, and that we can show the time of appearance by a label. So how can we do that on a map for various locations? If they have appeared at the specific date, we just highlight those by a specific text. We can color code them, or we can become more interactive and focus on this image. This image is using the space-time cube. So the x and y axes, these are showing the geographic locations, and then the z is time. So now each of these circles is an event that is happening over time. So whenever it's closer to 0, it's earlier in time, and whenever it's up here, it's later in time. This is another example of using the space-time cube to kind of think about the same information, but rather than different events, this is a progression of one event. So how do we think about location changes when something is moving? We can use a static representation of routes in a single map by connecting different locations with line. We have 3 different ways of doing that. We can use a snapshot of time. So at each display moment, the map shows only the position of the objects at that moment. We can think of movement in history. So when you start at a location, you will draw a line up until the point where you are currently. So you will see all the history of the movement. This is powerful, but it could be kind of complicated and complex when there's a lot of data points. Or we can think of a time window and think of certain number of previous steps. So only show the 10 previous minutes of locations and disregard the rest of them. So this is an example of a snapshot in time. So at every moment in this animation, we're looking at the current position of the airplanes. We could also think of the same kind of movement, but showing where they have been. As you can see, these are showing 2 very different but related types of information. So now let's talk about exploratory techniques for specific data analysis tasks. So now let's focus. The previous ones were all general techniques that would be applied to everything. Now let's focus on when we know the time and we want to get to a what and a who. We have 2 types of tasks. We have the identification task that has the goal of determining characteristics of spatial objects or locations at a given time. And then we can think of comparison tasks to detect changes between 2 different objects, or to detect pattern changes between a set of objects. For these kinds of tasks, a map iteration is good, but it has its own drawbacks because it helps you to detect the changes, but it will not allow you to measure how much things have changed. So to do that, to measure, the best method is to overlay different maps to each other so then the user can easily compare. So this map is an example of such change over time. We can see that the colors, the brown, yellow colors are showing increase, and the blue colors are showing decrease in population and unemployment. You can see a clear spatial pattern of change, decreasing of the unemployment rates in the north and increasing in the south. But using the map iteration method, we can kind of depict this information much better to show the changes in a better way. But we can ask the question in terms of comparison. So when was the unemployment rate of Rome lower than that in Pisa, right? So one example is that we have the maps, but then we will use a time graph. We will modify the time graph to show a line that is for Pisa, right? And then the rest of the cities, we can easily find whether they are higher than that or lower than that. And then by selecting those, we can see those areas on the map. Now, let's talk about general tasks with respect to time. Analysts can identify the behavior of an object or location by observing it during map animation or a series of maps referring to the consecutive time moments, filtering facilities on a particular object among other objects. Um, we have a comparison of behaviors as an important task, comparing homogeneous behaviors, for example, comparing the movements of white storks X and Y, or comparing the dynamics of average house prices in cities A and city B. Or we can compare heterogeneous behaviors. For example, relate the movement of stork X to the air temperature and precipitation at visited sites, or compare the dynamics of average house price and unemployment in city A. For moving objects, in general, for general tasks, we can think of snapshot in time as a suitable for exploring movement of a single object, but it would be too complicated when we have a lot of them. Movement in history, however, can prevent the analyst from losing track of a lot of them. You know, when we are looking at maybe 100 different movements in time, but that might become too complicated. So the authors here recommend using time windows, which limits the amount of history that is shown for every object to a specific time window as the most suitable for these kinds of tasks. Now, for single objects, to compare behaviors on the same territory during the same time interval, for example, we can think of dynamics of rainfalls and vegetations. We can think of comparing general behaviors on distinct territories during the same time, for example, comparing the process of city growth in France and Germany. And then we can think of comparing behaviors of same territory during different time intervals. For example, comparing the spatio-temporal variation of air temperature over Germany during the first and second weeks of June. As you know, let's have it in mind that we're talking about the general level of reading data and analyzing data. So this is an example of that. We're using the map iteration technique, and we have an animated representation of two continuous phenomena: rainfall and vegetation, overlaid in the same map display. The blue color, which is not shown in this map, because I took it from the paper, represent rainfall values, and the green color, probably, which is the lighter gray, used for vegetation index. Now let's move to when we want to query what and where, and then get to the time. This kind of general task involves search for time intervals during which a specific behavior took place. Map animation in general appears to be quite suitable for this task, and a lot of those techniques that we talked about are applicable. So this animation kind of gives us a very good example of what we mean by that. We can kind of show the changes of objects given in different times, given a specific. So this image is a great example of what we have been talking about. So these are three different views that are linked to each other. A sequence of events occurring at the same place within a short time period is manifested in a space-time cube by vertical alignment of symbol. So that's the upper left image. The dynamic link between the cube and a map display helps the user to locate the event sequence in space. So as you can see, when you select those little dots in the space-time cube, you see them on a map and can see what they are, what types of events they are, right? And then the movable plane, which is the below map, is moving the map in the vertical to show you the time. So you can, you can simultaneously understand the what and where given the when. So to kind of wrap up what we have learned and to cover up the different ways of thinking these authors have introduced about spatio-temporal visualization, we have few things to remember very importantly. Most important than all, in my opinion, the categorization of the task based on the objects, so what, when, and where, the reading level, general, elementary, and single, and then the cognitive tasks, comparison and identification are very important frameworks for anyone who's trying to do spatio-temporal visualization to use. We have seen also a collection of different techniques and methods for our future works, and of course, this is by no means a comprehensive list of all the different ways that you can show spatiotemporal information. Now I can get any questions, take any questions that you guys have. Thank you very much.